So I'm going to talk to you about what it means, this term, oxidation numbers. All right? And oxidation numbers are used to help us write chemical formulas. All right? Oxidation numbers, these are very important. And oxidation numbers really are related to, the word oxidation comes from combining with oxygen. All right? Now, that's how it first came up. Right now, I'm going to go ahead and tell you the oxidation numbers. You want to write this down. The oxidation number of group 1 is +1. The oxidation number of group 2 is +2. And then we don't know the oxidation number of these unless somebody tells us. The oxidation number for group 13, or really I like to call this group 3, is +3. The oxidation number for group 4 is plus or minus 4. And then we have -3, -2, -1, and nothing happens here because they don't bond. So you really need to write that down. I'm gonna go ahead and make that neater. Plus or minus 4. Now, this is not something you'll memorize. It's something you will learn because it makes sense. It makes sense. All right? Check this out. What does a Bohr model, all of these Bohr models right here, all the Bohr models, ooh, I went off the edge of the screen there. There we go. All of the Bohr models in group 1, how many valence electrons do they have? 1, because they're in group 1. So this is going to be hydrogen, and then we have bigger. I'm not drawing the inner shells, okay? I'm just drawing the outermost shell, all right? So all of them have 1 valence electron, correct? So if we looked right here, and I drew, say, let me see if it'll show up here. Let's say I draw lithium, right? Here's lithium. Here's lithium. When it bonds, what happens to this electron very easily? Is lithium very electronegative? No. It has a very low ionization energy, correct? So what happens to this electron very easily when another atom gets near it? It's taken. That's right. So once it's gone, lithium ends up with a charge of +1, right? Because it still has the 3 protons, but now it only has 2 electrons. That's what this +1 means. Does that make sense? And if we talked about all of these atoms, they all have 2 valence electrons. So when they lose their valence electrons, right, they end up with a charge of what? +2, right? These guys right here, they have 3 valence electrons like aluminum. And we can't go all the way down here really, okay? So they end up with a charge of +3. Now we're right here in the magic. These guys, the carbon group, we need to think a little more about. Okay? Let's draw a carbon atom right here in the middle of the periodic table. Boom. 1, 2. 1, 2, 3, 4. All right? Now we're thinking about this carbon atom. Is this carbon atom more likely to gain 4 electrons and get up to the number 8? Or is it more likely to lose 4 electrons and lose the shell? It's neither, because it's at 4. 4 is halfway between 0 and 8. Does that make sense? So sometimes it could gain 4 electrons and have a charge of -4. And sometimes it could lose all its electrons and have a charge of +4. So when we talk about the oxidation number for carbon, this group right here is plus or minus 4. You don't know what they're going to do. Does that make sense? You know these guys are going to lose 1. These guys are going to lose 2 electrons. These guys are going to lose 3 electrons, but these guys are right in the middle. If 8 is the magic number, then you don't know where you're going to go from 4. Does this make sense? All right? So now we're over here to nitrogen, right? How many valence electrons does nitrogen have? 5. That's right. Look, 1, 2, 3, 4, 5. So if we have all these guys, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, etc., then they're more likely to gain electrons. Let's take a look right here at nitrogen. Here's nitrogen, 2, 1, 2, 3, 4, 5. It only needs how many more electrons to be full? 3. So when it gains 3 more electrons, it has a charge of -3. That's its oxidation number. When it bonds, that's what ends up happening to it. Does that make sense to everyone? So everybody in this group's -3. Oxygen, it's got 6, 1, 2, 3, 4, 5, 6 valence electrons. How many is it going to gain? It's got 6, so it's going to gain 2 more. It's going to have a charge of -2. And then look at fluorine, or 1, 2, 3, 4, 5, 6, 7. How many more electrons is it going to gain? 1, and it's going to have a charge of -1. Does that make sense? So now that we've done all this, we know what oxidation numbers are, and now we can do some simple formula writing. We can now, for the first time in chemistry, write some chemical formulas, right? We're going to do that in the next video.